In this video tutorial, we're going to go over the differences between homogeneous mixtures and heterogeneous mixtures. So, let's get started. Alright, so we're going to take notes in the form of a concept map, and so in your Cornell notes, I want you to start off at the very top and I want you to write down homogeneous mixtures. And underneath, I'm going to put a little asterisk, and let's define homogeneous mixtures. Homogeneous mixtures, one, that the parts are uniformly distributed throughout the mixture. So uniformly distributed, that means that when you look at a homogeneous mixture, you can't tell that there are multiple parts to it. Think maybe salt water. The salt has completely dissolved throughout the water. That's an example of a homogeneous mixture. You can't pick out the salt. You can't pick out the water. It's a little bit more difficult to separate. So one thing that I want to add to our concept map is that homogeneous mixtures exist only in one phase of matter. All liquids, for example, or all solids or all gases. You're never going to see a homogeneous mixture that has more than one phase of matter. For example, you won't see one that has a liquid and a solid in it. It doesn't work out that way. So a couple of things about homogeneous mixtures is that they are difficult to see individual parts of the mixture. So when you look at that salt water, you can't tell that the salt is dissolved in it. The other thing about homogeneous mixtures that's difficult, it's difficult to separate. You can separate them. Think about it. We are able to separate salt from water, but it's difficult to do it. We have to add a bunch of energy to do it. So usually homogeneous mixtures are difficult to separate. Let's talk about a couple examples. So one example of a homogeneous mixture is the air that we breathe. The air that we breathe is made up mostly of nitrogen gas and oxygen in there as well, some other stuff too, like carbon dioxide in various percentages. Another example of homogeneous mixtures, Kool-Aid. You take water, you take some coloring, some sugar, some flavoring, you add it all together, you mix it up perfectly, it's homogeneous throughout. You can't tell when you look at the Kool-Aid whether or not it is the sugar's on the bottom, the top. No, it's all throughout, right? Uniformly distributed. Another example of homogeneous mixture is liquid soap. There's a bunch of ingredients to liquid soap, and you can't separate them. Very difficult to separate. Going back to the air example, think about air, nitrogen gas, oxygen gas, carbon dioxide gas. All of those exist in one phase of matter, in this case gases. Again, only homogeneous mixtures can exist in one phase. All right, so how about another one? Brass. Brass is made up of zinc and some copper, maybe even some other metals. Brass is an example of a homogeneous mixture that exists as all solids, right? So we can have different types of mixtures. Let's talk about heterogeneous mixtures. So I'd like you to create a brand new concept map below the concept map that you just created. So let's define heterogeneous mixtures. Heterogeneous mixture is one in which the parts of the mixture are not uniformly distributed. When you look at a heterogeneous mixture, you can tell that there is two parts to it. Think about sandy water. Sand exists as a solid and the water exists as a liquid. You can separate those pretty easily. In fact, let's write down a couple more things about heterogeneous mixtures. With a heterogeneous mixture, there can be more than one phase present. Some of those phases can include solids, liquids, and gases. All right. So the thing about heterogeneous mixtures is that they are they're easier to see individual parts of the mixture. Think about sandy water. You can see the sand, you can see the water. Another part about heterogeneous mixtures is that they're easier to separate. We can decant the water from the sand and we're nice and separated. Let's write down a couple examples of heterogeneous mixtures. One example of a heterogeneous mixture is about vegetable soup. Vegetable soup is made up of water, salt, but then all of those different vegetables throughout. You can pick out those individual parts of a vegetable soup. And if you can see that a mixture is not uniformly distributed, then it is absolutely a heterogeneous mixture. Another example of a heterogeneous mixture is cereal and milk. Think about it. The milk is a liquid, the cereal is a solid, and we've got two phases present, heterogeneous mixture. Another example is iced soda. Think about how easy it would be to separate the components of iced soda. We have solid water, we have a bunch of liquid water in the form of soda. We can take the ice out very easily. If we can separate the components of a heterogeneous mixture, then it is a heterogeneous mixture. And how about some salad dressing? Salad dressing is made up of vinegar and oil, and those are easily separated, easily distinguished too whenever it sits around. So what I'd like you to do is come up with a couple more examples of a heterogeneous mixture, and I'd like you to also go into the homogeneous mixture part of your concept map and come up with a couple examples there as well. If you had any questions about this, give me a raise your hand, and I'll be more than happy to help you.